Suppose we know these bits and pieces about the events E and F. So the P of E is 0.26, the probability of F is 0.41, and the probability of E intersect F is 0.16. If we're trying to find all of these values, well, the probability of the union, we could actually just use the straight good old-fashioned union rule here. It's the probability of the first plus the probability of the second minus the probability of the intersection. It gives me 0.26 plus 0.41 minus 0.16. When I add all that together, we get 0.51. So that's one way of going about it. Alternatively, well, whenever we're using the union rule, you could always think of them in this way. We have our two sets here, E and F. I'm just drawing a Venn diagram because it's representing kind of a more in-depth version. We can see complements in addition to seeing the sets themselves. But when we're dealing with the union rule, essentially what we're doing is we're saying, well, there's 0.16 in the middle here. In total, this area is 0.26 and this area is 0.41. So if I just add these three numbers together, I would be adding that 0.16 twice, and so I end up subtracting it off the one time. If we do this using these Venn diagrams, you can see in order for there to be 0.26 within E, there would have to be 0.1 within this crescent moon shaped area, because 0.1 plus 0.16 is 0.26. Or another way of looking at that is 0.26 minus 0.16 is 0.1. Similarly, we know that the probability of F is 0.41, so this whole region here must be 0.41. So if I wanted to just have, or if this area right here is 0.16, that means the remaining stuff would have to be 0.25. Alright, well, I filled in three of the four regions of this particular Venn diagram, so it kind of makes sense that I would want to fill in the remaining region out here, or the stuff that's outside both E and F, but still inside our sample space. We don't call it a universal set when we're dealing with events, we call it a sample space, but it functions the same way. Since we're dealing with probabilities here, I know that the sum of all the different things that could happen would have to sum up to 1. You could figure that out using your complement rule, or there's a couple of different ways to come about that. But let me pull up in my calculator here. We have a total of 0.1 plus 0.16 plus 0.25. This is the stuff that's already accounted for within these various numbers, and you can see, of course, that is the 0.51 we just found here, the probability of the union. And using our complement rule, the stuff outside the circle must be 1 minus that, which is 0.49. So the reason we would go about using the Venn diagram as opposed to just using the union rule, well, for this one it didn't really make sense to use the full Venn diagram. The union rule got us the answer, and it got us the answer quickly. But if we wanted to do any of these others where we start talking about things involving their complements or probability of a different intersection, we have to know more about the scenario. So that's why the Venn diagrams come in handy. So if I wanted to find the probability of E complement intersect F, so E complement, let me think about which areas are E complement. It's everything outside of E. It's all of this stuff. That's E complement. But I also want it to be inside F, so scratch out any areas that are not also inside F. We're left with this region right here, this crescent moon shaped region right there. And you can see that that area is 0.25. If we want to do E intersect F complement, well, we're inside E, so we're over here, but we need to also be inside F complement. Or another way of saying that is we need to be outside of F. So it kind of gets rid of this intersection region. We're looking at this region right here. So we would have an area of 0.1. Alright, so for this last one, thinking about which region we're talking about here, we're doing a union of two regions. So if I start off with E complement, that's everything outside here. And we want a union on F complement, well, that means we also include this region here. So we're doing everything except for the 0.16 there. So we would want to take 0.10 plus 0.25 plus 0.49, which gives us 0.1 plus 0.25 plus 0.49 gives us 0.84. Of course, I said it's everything except for this 0.16, so I could have also used the complement rule. I could have said 1 minus 0.16, which also gives us the 0.84, knowing that the sum of everything is 1. So if I'm talking about everything except for this 0.16, you know, all of these regions, all the shaded stuff there, that would sum up to, well, 1 minus 0.16, which is 0.84.